Experiment 10 is about test for carbohydrates. The objectives of the experiment are to use chemical tests to identify functional groups in carbohydrates and to determine the identity of an unknown carbohydrate using the chemical tests. The unknowns are assigned according to the last name. If your last name starts with A to F, you're going to be using only unknown A. Last names G to L, unknown B. Last names M to R, unknown C. Last names S to Z, unknown D. You're just going to be using one unknown. Experiment 10 lab report. You are going to fill up this table. So the observations, we have 4 carbohydrates, glucose, fructose, sucrose, and starch as the standard. And then you are going to also do one unknown, either A, B, C, or D, depending on the assigned unknown letter, depending on your last name. And then you are going to determine the identity of the unknown based on the observation. So you will have, you will fill up Benedict's test observation, Seliwanov's test observation, iodine test, and it should only be one unknown. And then now identify the unknown for either A, B, C, or D. Part A is Benedict's test. We're going to be using the sugars, and then we're also going to test an unknown sample. So for now, I labeled already the tubes. So glucose, fructose, sucrose, starch, and then the unknowns labeled A, B, C, D. I already put 10 drops each in each of the tubes. So the way I do it is I use the dropper. Okay, so I left one, the starch. So basically I just use a pipette, and then again 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the sample for the starch. And then I'm going to now add, so I added already 10 drops each. Okay, fructose, sucrose, starch, A, B, C, D. So I'm now going to add the reagent, which is Benedict's reagent, Benedict's solution. So it's already made up, and I'm going to add 2 ml of the reagent, mix it, and then I'm going to heat it up in the water bath for about 3 to 4 minutes, and then we will compare the results in terms of the color and then in terms of how fast the reaction happened. So now I have here Benedict's solution. It's blue. It's copper plus 2. And then I'm going to add 2 ml each on each tube. So I'm using this pipette. This is 1 ml, so I'm going to add twice. Okay. So the solution is blue. All right. So 2 ml each. 2 ml. So I want to have almost the same amount, so I'm gonna try to make it almost the same so we can make a comparison. Okay, right? And then next sample, sucrose. then starch. So nothing really is happening at room temperature. Something will happen once we heat up the solution. So now we're gonna do the unknowns. A. So there are 4 unknowns. You're just gonna be responsible to the assigned unknown, depending on your last name. Okay, so again, the unknowns is gonna be either one of the 4. One of the 4 known solutions that we're testing. Okay, so that's A, and we're now doing B. So B. Now I'm doing now C. Last one is D. So 4 unknowns. Okay, so now we're gonna heat it up. When you heat it up, it eventually will mix up. So gonna get mixed, but I will mix it up a little bit. Okay, and okay, then I can put it here. Right. So I need a stopwatch. So temperature right now is about 78. Okay. Then we're gonna observe what happens. 50 seconds. Let me take that out. So this one turned, so the fructose actually turned reddish. So I'm gonna take it out. Okay, so now for the unknown, I see that C also turned color. So I'm gonna put it back in here. And then now the glucose changed color. Okay, so it's not deep blue anymore. So the first ones that reacted actually was the fructose and also letter C for the unknown. And then next is glucose. I'm gonna take out this D because it already changed. Okay, so alright, same as that one. So you can now make a conclusion. So 20 more seconds, and then I'm gonna stop. Stopwatch. It's like 5 minutes already. And then so I take out the sucrose. Sucrose is still blue. And then this one is A. Okay, so that's A. And then this one is B. So that's B. And then this is also starch. Those are our results. So glucose, fructose, sucrose, starch, A, B, C, D. So part B is the Seliwanov's test, and it's a test for ketosis. And I already have the sample in here. So it's labeled as glucose, fructose, sucrose, starch, and then the unknowns A, B, C, D. And then I am going to put 2 ml of the reagent. This is the Seliwanov solution. And then 2 ml of these in each. And then I will put the cork and then vortex and then heat it up. So 2 ml. So the solution is slightly yellowish in color. So I have 2 ml added, cork it, and then mix. And then fructose. So 2 ml. And then again cork it, vortex. And then now this is the sucrose. So again cork. So 1. Just to check that I have equal. Okay, so again, so those are the standard. I'm not doing unknown, so this is unknown A. So again, 2 ml. So that's A. And then B. So again, you're responsible only for the assigned unknown for you. Okay, so that's B, right? And then C. Vortex. And then last sample. Okay, and then vortex. And then now we're gonna put these into the water bath, and then we're gonna set the timer. So we're gonna determine which one will react first or change color. So I'm now gonna put everything in here. So I'm gonna start it, timing, and then we're gonna watch what happens. Okay. So I put everything. So let's take it out. It's like 5 minutes already. And this is number 1, which is the glucose. And then number 3, sucrose. And then number 4 is starch. So you can see that glucose and starch did not change color from the original color. However, fructose and sucrose changed, and fructose is a little bit more intense, and it changed color about 5 minutes, and this one is about 6 minutes. So now if I take this out, this is C, and then this is A, and then this is B, and then this is D. So now let's review this. So A, B, C, D, and as you can see, B and C did not change color. However, A changed to a little bit orangey color, and then C is much more intense. So if you can see, okay? So this is A, and this is C. So A, B, C, D, all right? And then glucose, fructose, sucrose, and starch. So now you can make a conclusion about the identity of your unknown based on the standard solution. So now I'm doing the iodine test. And I have here already the so the sample, glucose, fructose, sucrose, starch, they're all 1%. And then I'm gonna put in the, so we have the spot plate, and then I'm gonna put here glucose, fructose, sucrose, starch, and then the unknown A, B, C, D. So we're gonna match the color. Okay, so I will put 5 drops each of the sample. So I have here glucose, and then 5 drops. So this is glucose, okay, and then I have fructose. So these are the known samples. So fructose, again 5 drops. Okay. And then next one is sucrose. So sucrose, third sample, again 5 drops. Okay. And then starch. So they're all 1%. So starch. Okay, so we have the unknown here. Okay, so I'm gonna put, so the same amount. All right, so I'm gonna put 5 drops. So I labeled it, I color coded this 1, 2, 3, 4, 5. And then B. One, 2, 3, 4, 5. Just trying to avoid that I don't put in the other well. So C. 1, 2, 3, 4, 5. And then D. 1, 2, 3, 4, 5. Okay, and then I'm now going to add 1 drop each of the iodine. Okay, so 1, 1, 1, 1, 1, 1, 1. So now you can see that for glucose, fructose, sucrose did not change color. Iodine actually, by the way, is slightly colored. So there's a slight coloration. The iodine is light yellow. It's light yellow. And so now you see that A, B, C, D sample, so you can figure out what the sample is. So A, that's the color, light yellow, B, blue, C, and D are the same color. Okay? So observe, record the observation, and then record any color changes in the table.